Okay guys, we started with an activity today that looks like this, and there were two rules to start with. So the first rule is every one of these is balanced, and you have to assume that they are balanced. The second rule is that for each problem, each box has to be filled in with the same number. Not necessarily on the whole page. 5 might be a different number than 6, but whatever those boxes are, it has to be fill in the same number. So pause this and see if you can figure some of these out, and then come back when you think you got some answers. Okay, welcome back. So we started by going around and saying, okay, which one of these was easiest? So a lot of people said, 2, 5, and started throwing out some things. So we started talking about these and said, okay, what would you fill in for number 1? So some groups filled in a 4 and a 4. Some groups filled in -2 and -2. Some groups filled in 303 and 303. And all of those answers worked. So every group was wrong, every group was correct, even though they had different answers. Number 2, we said, okay, what does this have to be? And a lot of people in every group had the same exact answer. They had to be 8s. It couldn't be anything else but 8s. Correct. 3, we had some trouble with. 4, we had like a 10, a 10, a 10, and a 10. Some people had -5, -5, -5, -5, and so on and so forth. And every group had different answers, but they were all correct. For something like number 5, we realized, it had to be 10, and every single group had that same exact answer. And number 6, people wanted to try to do different things for those ones, but we just couldn't find one number to put in for both of these that would make them balanced. So we said, okay, what patterns do we really notice here? There's 3 types of problems. There's 3 types of problems. Can you try to figure out, without me telling you, which types of problems do we have? Because this is really our lesson today. So what it ended up being is, well, these ones were kind of related, like number 2 and number 5 were related to each other because everybody had the same answer. Everybody only had that one answer. Right? These were the only answers that would work. Okay? Everyone had 8 and everyone had 10. So those ones were related to each other. The other ones that are related to each other that were kind of similar were these ones, 1 and 4. Because any answer worked here. Any number that we threw in here, these boxes, worked for everybody, and everybody had it correct. So really, there was an infinite number of responses here. Infinite number of responses here that are acceptable. And then for these last ones, for this problem, 3 and 6, we realized, wait, there's really nothing that will work. It's really not possible. Nothing works here. And nothing works here. And these are the 3 types of problems that we're going to talk about today. You can have infinite answers. You can have only one answer. These are what we're used to, and we're really good at these. And you can have solutions where nothing works at all. So here's what your notes look like. Okay, you have a sheet like this. Okay, to fill and get it into your notebook, what you're going to want to do is you need to tri-fold this so that it's ready to go. And on the outside, kind of like a brochure, and on the outside of that, you're going to write the 3 kinds of solutions. Okay, and this is what we're going to kind of go over today and fill out your notes. So take good notes from these. Okay, so here's the first kind that we're going to go over, and this is the kind that you already know. You're really good at this type of solution already. So if you look at kind of the balance, kind of like the problems that we were looking at before, you would really kind of fill these in with x's. And this is where there's only one answer that really works. Okay, so if we were to actually write this as an equation, well, this side is represented with 4 x's equals, this is the balance, equals 2 x's plus another 6. Okay, well, now how would we go through and solve that? Well, we would do what we normally do, right? We would do minus 2 x's, minus 2 x's. So we're left with 2 x's equals the 6. right? So if we were to, and then we can keep going here to solve that. So we can talk about like what this would look like as the balance a little bit more simplified, right? 2x's plus 6. Well, what does x equal? Divide by 2, divide by 2, x equals 3. Okay, so x equals 3 here. You get one solution. There's only one possibility. These are the ones that we're really good at. We're used to getting x equals something. This is what we know. So this is nothing new to you. Okay, this is what you're used to. So if you get an answer that you're used to, great, move on to the next problem. Okay, the next type of problem that you're not so used to looks like this, no solutions. So no solution means that there's no possible number that could work at all. Well, what does that look like in an equation form? Okay, you'll get something like this, x plus a 3, and it'll look more complicated, the ones that we're going to do, but when you simplify it and distribute and you boil it all down, this is kind of what it'll end up being. So you'll get something like this, and then what do we do first to solve? Well, we move our variables all to one side first. So we would do the same thing here, minus an x on this side, minus an x on this side. So at the end of it all, I'll get something that looks like this. 3 equals 5. Those are the only things that are left. The x's are gone. We just eliminated the x's. I minus an x on this side, I minus an x on that. The x's are gone. I am left with 3 equals 5. And then you say to yourself, wait, what? 3 doesn't equal 5? That's weird. It does not. It is false. That is not true. You're right. So if you get a teeter-totter like this, 3 equals 5, for a teeter-totter, something's wrong, right? These scales, this really means what you're going to write is no solutions. That's what you're going to write. You're going to write something like this, and you're going to write no solutions. Because the scale could really, truly never be balanced in this situation. 3 can never equal 5. 2 can never equal 8. 0 can never equal -1. Okay? So remember, 0 can be a number too. Okay? This last one, infinite solutions, this means that any number could work in a problem. Where this one means nothing can possibly work, this one means anything can work, and infinite numbers could work. And here's what the equations kind of boil down to. X plus 4 equals x plus 4. And realize that as we go through and we write these, that they're not going to be quite this simple as you go through and write it. You could end up with something that it was x plus 4 on this side, and it was a 3x plus a 1 minus a 2x plus a 3. So when you go ahead and simplify that, it is going to simplify down to x plus 4. So it's not going to typically look as straightforward as this. Okay, so anyway, when we go to solve this, you're going to say minus x again. We always move our variables first to one side, minus x on that side. So we end up with some, at the end of it, after you've moved your variables and you've solved for some things, you end up with an answer that looks like this, 4 equals 4. Your x's are gone, and you end up with two numbers that are equal to each other, and you say 4 equals 4. Oh, wait, that's true. Okay, if you get something, you're like, oh yeah, that does equal that, then your answer underneath, you would write infinite solutions. Because yes, anything that you plug in for x would work in this case, because 4 equals 4, it is infinite. Oops, I can spell, I swear. Infinite solutions. And this is literally what you write, is infinite solutions, because the scale is always balanced. Doesn't matter what you put on both sides. If I add an x on this side and an x on this side, or if I add two things to that side, it doesn't matter. This scale is always going to end up being balanced. So you could end up with something like 4 equals 4. You could end up something like 0 equals 0 would work, and that would, it does not mean that x equals 4. This does not mean x equals 4. It means 4 equals 4, which is true. The only time it's equal to one thing is when you truly solve it down to have an x left on this side equals 3 or something like that. Okay, so the only thing that was really different about these two right here, this is what we're used to doing. The no solution and infinite solutions, you need to make sure that when you solve it all the way down, and yes, you cannot just stop here and say infinite solutions, you need to solve it all the way down. You need to realize that all your variables get eliminated. All your variables get eliminated when you're solving for this type of problem and when you're solving for this type of problem. So realize when you're minusing x on both sides, your variables do go away, and that's okay when your variables go away. That means you're going to get one of these type of problems. When they don't, it's over here. So there are your notes for all of this. Let me pull back in case you need to fill anything else in. So there's your notes. And then your homework can be found on Big Ideas. Thanks.